This is an interesting problem. We didn't really get into this deep, but don't let this throw you. Think of it like this is cosine of 2 theta. So you're going to have to access that note card again and use one of your rules. One of them is cosine squared theta minus sine squared theta. Well, it just so happens that our angle is this thing right here. So let's come down here and replace our angles with arc sine 1/4. Okay, so that's what we have. So we need to draw this out and figure out what's going on. Sine's 1/4. So let's draw a picture. It's positive, so we know it's first quadrant. Sine is opposite over hypotenuse. We've got to figure out the other side. So 1 squared plus I don't know squared equals 4 squared. So that's going to be 1 plus x squared equals 16. So x equals square root of 15. Can't do anything with that, so he's just going to sit there. Now, that means we're using this picture. We want to do cosine squared of that picture. So don't lose your square. Put him down there. And then we're going to do sine squared of that picture. So cosine of this picture, so that's adjacent over hypotenuse. And then we're going to do sine of this picture, which is 1/4. And then we're going to go through here. You have to square them both out. So when you square the square root of 15, it's just 15. But don't forget to square the bottom, 16. And then when you square 1/4, you got 1 over 16. Thankfully, the denominators are already the same. And so that's going to give us 14 over 16, which, yes, you're required to reduce. That's 7/8. So it started out kind of nasty, but just realize that what they gave you was a double angle formula, and the angle was just a little odd. Okay? So on number 82, this is the same idea. Think of it like this. Cosine of A plus B. So you're using your expansion rule, your sum rule. Cosine, cosine, sine, sine, sine. So we're going to do a cosine of A, and then we're going to do cosine of B, and it's going to change. And then we're going to do sine of A, sine of B. But when we do A, we're going to do this picture right here. And B is this right here. So if that's, if it weirds you out and you don't want to write all that, then just know what you label. So let's do A. Here's A. A situation is where sine is 3/5. It's positive, so it's first quadrant. Opposite is 3. Hypotenuse is 5. This is a special Pythagorean relationship. There's a 4 down there. So now let's draw out the picture for B. B says cosine is positive square root of 3 over 2. So it's got to be in the first quadrant. And the adjacent side is square root of 3. The hypotenuse is 2. So this is a special unit triangle. The opposite side is 1. So we should be able to get our information from these pictures. We want to do cosine of the one we labeled A. Cosine of that one is 4/5. Then we need to do cosine of B. Okay, well that one's going to be square root of 3 over 2. And then come back and do sine of A. That's 3/5. And then we're going to do sine of B, which is 1/2. So now it's just a matter of can you multiply your fractions. You've got 4 square root of 3 over 10 minus 3 over 10. Thankfully, the denominators are already the same. And you're just going to put your numerators together. And I do believe, yes, that is the answer that they got. So it just looks a little strange, but all it is a sum rule. Okay, let's see how far we can get with this. Solve the equation exactly over the interval of 0 to 360. So basically, you want everything that works in the original circle. Guys, this is squared. You have a quadratic term. You have a linear term. You're factoring. Don't freak out on me. It's just this problem. You must factor. This is the hard kind with a coefficient. This is your monkey face for you juniors. Y'all do it with the bottoms up stuff. But I'm going to do the monkey face. So I need two numbers that multiply to 3. 3 and 1. Okay, so the sine theta just works like my x. Don't freak out. Now I need two numbers that multiply to 4. And I've got to position them so that my middle terms will subtract to 1. So I don't need 2 and 2. I need to keep 4. But I don't want the 4 over here because 4 times 3 gives me 12. I want the 4 here. and put a 1 there. 4 times 1 is 4. But 4 times sine, this is 4 sine. And 1 times 3 is 3 sines, for those of you that forgot how to factor. Sines are different, and the big one is negative. So 4 is bigger, he gets to be negative, this one's positive. So we're completely factored. We need to bust this up into 2 equations. We have this equation, 3 sine theta minus 4 equals 0, and then we have this one, sine theta plus 1 equals 0. All right, just solve them out. Y'all, it's the basic rules of algebra. When I graded y'all's test, it was horrific. Algebra doesn't change. Just because there's a trig function in it, the rules of algebra do not go out the window. Okay, and over here, you're just going to get sine of theta equals negative 1. Okay, let me bump this up so we can draw. On the first one, that is not a normal situation. It's not unit circle because it's not negative 1, it's not 1, it's not 0. But it's also not a unit triangle. So you're going to have to pull out your calculator. We need to use the fact that this is positive. Sine is positive in the first and the second. So that's just more like a visual because you're really not going to do a whole heck of a lot with it. You need to pull out your calculator. Make sure it's in, well, we're going to do it in degrees and convert. So go ahead and swap it to degrees. And we're going to do inverse sine 4/3. Oh, wait a minute, that's over 1. So I got domain error. So this is no solution. We don't even have to worry about it. So we just have to wonder where is sine negative 1. All right, unit circle. Anytime it's 1, negative 1, or 0, it's unit circle. So we got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine is the back number. Where's the back number, negative 1? Right down here. That's 270, but you're not going to give me 270. You're going to give me 3 pi over 2 for the radian equivalency. Okay, let's see if we can bump out a few more. Okay, we're going to solve this one. Again, the rules of algebra do not change just because there's a trig function in there. Tangent of x is negative 1. Remember, tangent being 1 or negative 1 is not the unit circle. That is triangles. Tangent only goes in the unit circle when it's 0 or undefined. Tangent is negative in quadrant 2 and in quadrant 4. So for tangent to be 1, remember that's the opposite sides have to be 1. That's how you're getting the negative 1. That's the square root of 2. So this is a 45-degree angle. 45 is the same thing as pi over 4, right? So think about, you missed a whole pi by pi over 4. So it's 3 pi over 4. And if you got pi over 4 down here in the fourth quadrant, remember this is 2 pi, which would make that 8 pi over 4. Take 1 off. 7 pi over 4. Those are your 2 values that are going to make that work. Okay, keep going. All right, you cannot divide by a trig function. So once you see that this is a quadratic and this is a linear, you have to push everything to the side with the quadratic. Quadratic's always happy. Okay, then you're factoring. You're factoring the exact same way that you've always done. You can take a sine out here. It's not a trinomial, so don't try to factor it like a trinomial. Okay, once again, you've got 2 equations. You have sine of x equals 0, and you've got 2 sine x minus 1 equals 0. All right, this one is ready to go. Unit circle. Where is the back number going to be 0? If the back number is 0, that means your y value is 0. You didn't get off the ground. So we're talking about 0 degrees or 0 radians and pi radians. So don't give me 0 and 180, give me 0 and pi. And then over here, we're going to move that 1 over and divide 3 by 2. So where is sine a positive 1/2? That's going to be triangles. Sine's positive in the first quadrant and in the second quadrant. Opposite, hypotenuse. Adjacent side is square root of 3. That gives you a reference angle of 30. 30 degrees is the same thing as pi over 6. So that's what you need to be referring with. Pi over 6 works for first quadrant, but in the second quadrant, you missed it by pi over 6. You didn't get all the way there, so that's going to be 5 pi over 6. So I need all of those answers. You need to pick the one that has them all. Okay. solve the equation exactly over the interval. It's the same business. But don't work yourself to death. It's already factored. So go ahead and bust it up. You got tangent of theta plus 1 equals 0. And 2 cosine of theta minus 1 equals 0. If you multiply that together, you're just like digging a hole for yourself. Take it easy. Take the gift as it's given. So where is tangent negative 1? We've already answered that question, so I'm going to fly through it. Tangent is negative in second and in fourth. That is 45 degrees, which is pi over 4. So we have 3 pi over 4, and we have 7 pi over 4. So we've already done that. This, once you move the 1 over, he's positive, you're going to divide 3 by 2. Where is cosine positive? That would be first and fourth. Cosine is defined as adjacent over hypotenuse, so the opposite side has got to be square root of 3. That's a 60-degree triangle, which means pi over 3. So pi over 3 works for first quadrant, but you got to figure it out for the fourth quadrant. So think about that. Double your denominator, that's 6 pi over 3. Take 1 off, 5 pi over 3. So again, we need all 4 answers. Okay, this one gets interesting because you're like, whoa, you're going to have to use some identities to get them to where they're speaking the same language. Go back and use your identity where you've got sine squared plus cosine squared equals 0. Or, you know, if you can think of something else that would work, by all means, go for it. Let's see, I've got sine squared would be 1, oh, I put 0, Lord bless, that's a 1. 1 minus cosine squared minus cosine squared equals 0. So this part was swapped, okay? Now combine your like terms, that's 1 minus 2 cosine squared theta. Once you get it down to one trig function, you should be good to go. That's just like having an x. So you're trying to get cosine by itself. So we can move this over so he becomes positive. So it'd be positive 2 cosine squared theta. Divide 3 by your 2. So we got 1/2 equals cosine squared theta. The last thing you do is take the square root. You don't start by taking the square root. Some of y'all did that on the test. All right, you can do the square root of the 1, it's just 1. Square root of 2, you're stuck with. But remember, you have to put plus minus out front. So, where's cosine positive, where's cosine negative? It's going to be all 4. You get 2 for each. And cosine, that's the adjacent side, is 1. The hypotenuse is square root of 2. That should let you know that's a 45. Reference angle of pi over 4. You got to go all 4 places. So, pi over 4. If you go into the next quadrant, that's 3 pi over 4. Then you got 5 pi over 4. And then you got 7 pi over 4. You got to have all of those answers. Okay, that's going to wrap it up for right now. We'll have to finish it up later.